Hi everyone, this video is the continuation of the coil tests, and in this video compared to test number 3, yes, this is going to be test number 4. In this test we will test the double coil configuration. So I seem to have found that adding a second coil here in some kind of a configuration, I think I could be also mistaken, because I thought I had a parallel configuration. It is, but basically the resistor is between these two legs of the coils. So here this coil is going directly in parallel, and this one here was also in parallel, but basically I break apart those two connections and put the load against it. And that's where I had found that with the coil on this side, I'd get very little drag effect with the magnet pass, and I flip the coil the other way and I'd get the drag back. So anyways, this I have no idea really how it's going to compare to the previous test, because this is being taped right away when I set it up, and we can all evaluate the efficiencies and the differences and see if there's any advantage using this double coil configuration. Maybe there is, maybe there isn't. Let's run it and see what we get. And right now, again, I'm set up with my Variac 67 volts. Is the same going to the Ryobi motor here to turn it. Same as test number 3. So let's power it up and see how she does. Alright, so there we are. It's turning with the double coil configuration, and let's check out what we have as far as RPM. Should be pretty well the same. It starts increasing a little bit as it gets warmed up, so we're at 35-30, and it might step up a few more, maybe 35 as it gets warmed up. So I'll let it warm up a little bit to get a stabilized reading. Okay, so this is a view of the scope shot of the coils, and as you see there's an extra bump, and that's most likely because there are two coils now happening one after another very quickly, so it makes an interesting waveform. Here, well, you have to keep in mind this is the setup with the double coil and being hit on one side of the coil, sideways, instead of the face of the coil. Alright, so now we're actually getting double hits on this configuration. Though when we'll do the test with the coil, with the magnets going onto the front of the coil as a standard generator, we won't have this kind of waveform here. Alright, here's the data on it right now. Keep in mind that this is unloaded condition, no resistor on the coil. It's open. Now, we have our meter here, and I'll put it on relative settings. So that's what we're drawing, 588 milliamps there. And let's do another RPM reading here. Okay, so we're at 35-34. Seems pretty stable at 35-34. And we're at 58.5. And let's do a relative setting here. So what we want to do is try to get a zero, a stable zero. There, I think we have it there. And now we go and load the resistor here. Here's my connection. Alright, so it's loaded now, and alright, I think we still don't have a zero situation yet. I took the load off there. Need to hit this at the right time when it's at the average. Alright, that's staying kind of stable there. Okay, we load the resistor, and we're getting, from what I see, about 7 or 8 milliamps in average. And actually the other previous test was about the same. The meter was going too much in the other direction. So it's identical to the previous test with the magnets going on the side of the coil. And this is what the waveform looks like. And what I'll do right now is I'll change my setting here so we get a bit of a bigger wave here. Alright, so that's what it looks like under load. And there is the data right there. So it looks like about 0.67 volts across that 1 ohm load in this condition here. And my meter there across the 1 ohm resistor is saying about 0.61. So let's say we got about 0.61 for sure across that 1 ohm load resistor. So I don't see any advantages using this configuration of the double coils using with the magnets passing on the side of the coil. Unless you can figure out something interesting, I don't see it. So now I'm going to stop the camera and set up the unit so we're testing the coil with the magnets passing on the face of the coil as a standard generator, and see if there's any advantages there as well using this double coil configuration. So I'll just stop the camera now and set that up. Oh, I just remembered, I forgot to show the RPM with the coil loaded and unloaded. So I'll disconnect the coil there, and here's our reading. So we're at 3536 with unloaded coil, unloaded resistor, and we're at 3533 with the resistor loaded. So 3533. So we've got about a 3 RPM drop with it. There it is again, unloaded, and 3535. So about a maximum of a 3 RPM decrease there, which is I think better than the previous, but doesn't look like the current goes down though. Anyways, I'll stop it. Okay, here we go. Both coils are now mounted in the standard generator position, the 2 stacked coils, and we'll do the test. There are the coils in the box, and it's turning. The RPM is at 3534, and here is the waveform with the resistor unloaded, and there's the resistor unloaded. And let's set our amp meter here so we have a relative point here. Yeah, that's pretty stable there, 0. Let us load the resistor here. And we're drawing probably about 7 milliamps with the resistor loaded. And we have 0.625 volts across our loaded resistor. And this is what the scope shot looks like here. Let me see if I can get it to get it up here so it can lock. Alright, there it is, and there is the data on that right there. The scope program says there's 0.68 volts across the resistor, and my meter here is measuring 0.63 volts across that resistor, and we're still again at our draw. I'll unload it to see if it... RPM is at 3543 unloaded resistor, and 3540 with loaded resistor. Well, that's about all I can do today. Thanks for watching, and bye now.